Today I'll talk about Gaussian Elimination Method. Here I'll show you detailed step-by-step solution. Here is the system of linear equation. So three equations are there. Equation 1 is 2x plus y minus z is equal to 8. Equation 2 is minus 3x minus y plus 2z is equal to minus 11. And equation 3 is minus 2x plus y plus 2z is equal to minus 3. So here is the key concept. First convert system to upper triangular form, and then we will do back substitution to find x, y and z values. So first convert these three equations to a augmented matrix. So these are the three equations. Now I am converting augmented matrix. So here coefficient of x is the first column, that is 2 minus 3 minus 2. Coefficient of y are in the second column, so that is 1 minus 1 minus 1, and coefficient of z in the third column, so minus 1 2 2, and others, that is after vertical line, so right hand side, all are constant, all of the equation 1 to 3, so that is 8 minus 11 and 3. Now here we have to make the triangular form. So here we have to make that upper triangular form, and then we will do back substitution. Now first, so this is my augmented matrix, and then first what I have to do, one operation to make first pivot 1. So here what I am going to do is, so R1 divided by 2, so I'll get new R1, and I'm making that 2 as 1. So if I do that, so new R1 will be 2 by 2, 1 by 2, minus 1 by 2 and 8 by 2. So new R1 will be 1, 0.5, minus 0.5 and 4. Now if I write that, the new matrix, so that will be 1, 0.5, minus 0.5 and 4, and other elements will be as it is. Next I have to eliminate first column row 2. So this is the matrix. Now what I am going to do is that I am going to this element make 0. How will I do that? So here operation is R2 minus A21 by A11 by R1. So that will give the new R2. So here A21 by A1 is nothing but, so minus A21 by A11 is nothing but 3. So new R2 will be R2 plus 3R1. So now if I do the operation, so minus 3 minus 1 2 11 plus 3 into R1 is 1.5 minus 0.5 and 4. Now if I do that, and I will get new R2 0.5.51. So my new matrix will be 1, 0.5, 0.5, 4, then this element is 0, 0.5, 0.51 and minus 2, 1, 2, 3. The third row is as it is. Now next is I'm going to do that minus 2 means first column, third row, this element will be 0. So now, so here is my step 2b, eliminate first column or third row. So here is my matrix. So 1.5 minus 0.4, 0.5.51, minus 2, 1, 2, minus 3. So how will I do that? So I will make one operation. So R3 minus A31 by A1 R1. So minus A31 by A11 is nothing but 2. And new R3 will be R3 plus 2 R1. So if I do that, so new R3 will be, so now we have old R3 minus 2, 1, 2, minus 3, then plus 2 R1, 2, 1.5 minus 0.5, 4. So now after doing that operation, we will get new R3, so that is 0, 2, 1, 5. So now if I write that matrix, so matrix will be 1, 0.5 minus 0.5, 4, 0, 0.5.51, 0, 2, 1, 5. Now this is my new matrix. After that, I'll make that second element of second row as a pivot element. So for that I will make that element 1. So what I have to do is that operation. So R2 will be R2 into 2. So new R2 will be R2 into 2. Why I am multiplying 2? So I am making 0.5 that element second row second column element. I'll as if that is as a pivot element. So I'll make that element 1. So now new R2 will be 2 into 0 into 0.5, then 0.5 and 1. So that will give 0, 1, 1, 2. So now if I plug that new R2, my new matrix will be 1, 0.5 minus 0.54, 0, 1, 1, 2, 0, 2, 1, 5. So now my next step will be make that third row second element will be 0. So then it will be the upper triangular matrix. Now for that, here step 4, eliminate second column. So here second column third row. So now for that what I have to do is that, so here that is actually R3 not R2. So R3 minus 2 R2. Okay, so that we have to do. So for that, so here is the some mistake. So R3, that will be R3 minus 2 R2. If I do the operation, so new R3 will be 0, 2, so 1, 5 minus 2, 0, 1, 1, 2. So that will give 0, 0 minus 1. So after doing the operation, so here this is the mistake. Okay, so actually that will be R3 minus 2 R2. So that will be new R3. So after doing that, so my new matrix will be 1, 0.5 minus 0.54, 0, 1, 1, 2, 0, 0 minus 1, 1. So after getting this matrix, so I will do the back substitution. So from this back substitution, I'll get x, y and z value. So if I do that back substitution here, so first that R3, so minus 1 z. So if I go back here, so in the last, so minus 1 z will be 1 because x is equal to 0 means third, we have to start from third equation. So here x is 0, y is 0, so minus 1 z is equal to 1. So minus 1 z is equal to 1 means z is equal to minus 1. Then from the second equation, so x is 0, y is 1, z is 1, so x is y plus z is equal to 2. So now I got that z is equal to minus 1, we plug that and then we'll get y. So here we got z is equal to minus 1, then from the R2 y plus z is equal to 2. So now substitute z is equal to minus 1, so we'll get y is equal to 3. Next, for that R1 we have that x plus 0.5y minus 0.5z is equal to 4. Now substitute y is equal to 3 and z is equal to minus 1. From that, if I do the calculation, so we'll get x is equal to 2. So now finally we get x is equal to 2, y is equal to 3 and z is equal to minus 1. So now if I check whether my whatever x and y and z we are getting, whether it is correct or not, so we will verify that. So equation 1 is 2x plus y minus z is equal to 8. So if I plug that x, y and z, we'll get 8, means that equation 1 is correct. So if similarly equation 2 and equation 3, if I put x, y, z value, so that will give, means the left hand side is equal to right hand side. So means whatever x, y, z we are getting from this getting after doing Gauss elimination, that are correct. So here x is equal to 2, y is equal to 3 and z is equal to minus 1. That's it. Thank you.